This is your lab about trying to figure out the percent copper and brass, and I just want to show you a couple of tools. You may or may not have already used the P5000 pipette, and it has one stop for your thumb and then a second stop. So the first stop is for filling the pipette, and then the second stop is for emptying the pipette. And so I'm going to, I already have these set to 5 milliliters, and you guys are going to bring your test tubes over, and you take your AccuMax P5000 and push the thumb down to the first stop, submerge the tip of your pipette into your solution, but don't push it against the bottom, because then you'll form a seal there and it won't fill correctly. And relax that thumb so that your 5 milliliters goes in, and then you're going to fill just one of your test tubes. Keep track of what solution goes in which test tube. And what I want you to see here is that when I empty it, I push my thumb all the way down. So when I empty my pipette into my test tube, I push to the first stop, and then I push to the second stop, which should empty the pipette and then put the pipette back in the beaker. The only purpose of the beaker is to hold the pipette. So imagine, if you will, each of your test tubes is filled with one of your 6 solutions, and you're going to be creating a fingerprint graph where you have the wavelength versus absorbance. So wavelength is on your x-axis and absorbance is on your y. So calibrate your SpectroViz just like you have been trained to, and once it's calibrated, you'll take your DI water out and you'll dump your DI water into the sink, and from your test tubes, fill your cuvette with one of your samples. Make sure you use the Chem wipes to wipe the clear sides of the cuvette, and as I just did, and place that inside of your SpectroViz. Now, before you hit play, I want you to connect your LabQuest to your computer so you guys can see the fingerprint graphs of absorbance versus wavelength. And so if you click here on the Wi-Fi symbol, you'll see an IP address. And what I want you to do is type that IP address into Chrome. So what you can see here is I've typed in the IP address into the address bar, hit enter, and you should see a gray screen as Vernier Data Share loads. We'll wait for that. So back here at your LabQuest, just hit home and the LabQuest app, and your sample is in there after calibration. I must have a copper sample in there since I'm blue, and hit play. Hey, very cool. All right, and over here, because you'll need to produce graphs, you have the data on your computer. To get this data onto Excel, where you can narrow the band of absorbance or of wavelength from 400 to 700, just like the lab describes, you want to hit stop recording. Once you do that, it'll auto scale. And once you have all of your runs here, if you click on this icon in the upper left-hand corner, you can do all of your samples on day 1 of this lab. And once you do that, you go over to this button right here and you download. You can put that in Excel and then make it look any way you want it to. On day 2 of your lab, you're instructed to take your copper nitrate sample. So you've got your copper that you put in nitric acid on Day 1 actually was before the weekend, and depending on what year you're watching this. And you're instructed to pour that into your 100 milliliter volumetric flask. Now, we've never used a volumetric flask in this class before, and so you'll pour it in. And whatever volume you have in there, you need to QS to 100 milliliters. Now, the cool thing about a volumetric flask is that this volumetric flask should be 100.0 milliliters plus or minus 0.5 milliliters. Dr. Moody, can you explain what QSing is? What's QSing?
It's Latin for quantum sufficitum, which means top it off exactly to the line that you want so that you have a sufficient quantity.
Thank you.
It's a pharmaceutical term.
So you can see the line here, if I can get this into focus. There it is. So the line right there, really faint line on your volumetric flask, you want to QS the water up to that line so that your meniscus, the bottom of your meniscus, or that dish of water tension at the top of your column, sits right on that line. And so let me show you how to do that. The first problem is that there's probably a lot of copper and zinc and iron left in this beaker. So clean that out with your DI water bottle and then pour that in. The next step is to use your DI water bottle to fill the remainder of your volumetric flask all the way to that line that's on it. That will be 100.0 milliliters. You don't have to watch me do that. Rolling. All right, so I'm just bringing the water up to the level of that line, which I overshot it a little bit. And at that point, you can use your pipettes to take water out if you do overshoot it. Now, I want you to pay really close attention to the fact that we haven't stirred it, we haven't shaken it, and that's what this stuff back here is for. This is called parafilm, and you should have a little bit of parafilm at your station. And you might even have like a little square of it like this. And so peel the paper backing off of your parafilm. So here's your parafilm. You peel the paper backing off of it, and it's really stretchy. It's like a very expensive, high quality saran wrap. And put that over the top of your volumetric flask and shake. And shake and shake and shake and shake and shake and shake and keep turning it back and forth and back and forth for a minute until the solution is perfectly stirred. All right, I think those are the major tips that you need to see for day 1 and day 2 of the lab. Good luck.